Alrighty, 3.4 is something that we'll look at in class. It's using Algebra Tiles. I will show you a little bit about that today as well. What we're looking at right now is factoring trinomials, and how we're going to do this is look at a bunch of different things, okay? I'm going to ask you first of all to remember what we did last chapter, which was last section, expanding binomials, and that would be looking at this here, okay? Now, if I was going to ask you to expand this, then what you would hopefully be able to do is that thing that we called FOIL. You remember FOIL, right? So, well, let's look at a couple different ways to do this. So, if I was going to do FOIL, you can see that it would be x times x, which is x squared, right? X times 2, which is 2x, 4 times x, which is 4x, and then 4 times 2, which is 8. And then what we do is we simplify this, we gather like terms, 2x and 4x gives me 6x, and I have plus 8. Now, another thing I'd like to show you is this thing that they call a rectangle diagram, okay? So you're going to have something that looks like this. Okay, and we're going to split it into 4. Boom. This is one of them, x and a plus 4, and an x and a plus 2. And then we just do the multiplications, right? So x times x is x squared, x times 4 is 4x, x times 2 is 2x, 2 times 4 is 8. And you'll realize that we add these two together, and you get the same thing. Okay, that's one way to do it. Another way to do it would be to use what we call algebra tiles. And I'm just going to show you these real quick. Okay, so that's an x, right? So what we can do is we go along this way. I go x plus 2, right? And then I go down the bottom here, x plus 4, right? Here we go, x plus 4. And then what you can see is that you're going to fill in 8 little pieces down here, right? So 1, 2, then you put them in there, 3, 4, okay, 5, 6, and 7, 8. Don't necessarily have to show them all, but I'm going to do them anyways for the first one just to show you. Okay, and what we've done is we've made a rectangle. You can kind of think of it as the same thing as the rectangle that we just did actually, look, right? It's almost the same in the sense that, let me slide this up, that's an x squared. Oh, sorry, I got it the other way around. So if you looked at it this way, well, let me put it up here. It actually looks kind of the same as the rectangle diagram, right? If I put an x and a 2 and an x and a 4. So this is your x squared. You can see this is your 2x. This down here is your 4x. And this over here is your 8. So we've kind of done the same thing. We made a rectangle, okay? Because it's a squared. So when you square things, you have 2 dimensions. Just another way to look at these things, okay? Here's a different one, 2x plus 1, 2x plus 1, and then x plus 2. So if we're going to FOIL this out, give it a shot. 2x times x is 2x squared. 2x times 2 is 4x. 1 plus x is x. 1 plus 2 is 2. If we simplify it, we have 2x squared. That gives us 5x, and we have a plus 2. Let's try a rectangle diagram with that. Okay? So 2x and a 1, an x and a 2, 2x squared, x, 4x, 2. That's going to give me the 5x. We end up getting exactly the same thing. Okay, so the rectangle diagram is kind of, we can do the same thing with algebra tiles. Hopefully you get a chance to play with them in the class, that you got a pretty good understanding of how they work. For some of you it's going to help, for some of you it's going to be unnecessary, as long as we get you through this, okay? Let's have a look at another one here. This is a little bit different because there's a negative involved. X squared plus 3x minus 2x minus 6. We have x squared, group that together, plus x, and then minus 6 at the end. So what I'm hoping that you're going to be seeing at some point here relatively quick is a pattern that's emerging. Let's try this last one. Notice that there's a little bit difference here because it's in a different order. Not that that should bother you. 8 times 3 is 24. 8 times negative x is negative 8x inside, negative 3x, and the last is plus x squared. So this will be 24 minus 11x plus x squared. Now this isn't something that I like so much in the sense that it's in the wrong order. This is called ascending order because it's ascending, it's going up. This is called descending order because it goes x squared, x to the power of 1, and then a constant, okay? So this should be somewhat familiar with you guys. We could model these all in a bunch of ways. What I'm going to show you quickly is this one here. In a rectangle diagram again, right? X minus 2, x and a 3, so x squared. That gives you a minus 2x. That gives you a 3x. That gives you a negative 6. Notice again that we're going to end up with the same thing, okay? So that, ladies and gentlemen, is the idea behind expanding. Now, what we're going to be doing now, though, is going from here to here. And what I'm hoping that we can do is notice that there is some sort of pattern here. I'm just going to write down the two answers here. So this and this are exactly the same. What I'd like you to understand is where this number comes from. This last number comes from multiplying these last two terms. So these last two terms always have to be a factor of 8, okay? Now, how do you get this little number in the middle? Okay, well, notice that we've always grouped the outside and the inside. So the 2x and the 4x, or the 2x and the 2x, or the 2x and the x and the 4x, the minus 2x and the 3x, right? So we always look at these two numbers. These are the key. These two multiply to give me the last, and they add to give me the middle. And that's always the case, okay? So we're looking primarily at polynomials or trinomials that have a factor of 1 at the beginning, or a coefficient of 1 at the beginning. Now remember this, okay, when we're factoring trinomials, okay, with a leading coefficient of 1, it means that they have a 1 at the front here. Now what I'd like you to write down here possibly is this, okay? So how can I write this down? When breaking, okay, so how are we going to do this? Look at all pairs of numbers, okay? All pairs that multiply to give you the last number. Okay, so in this case, we're looking at plus or minus. Okay, so here, what I'm always going to suggest that you do, okay, I do this, and then I put 2 pairs of brackets underneath. This is how we're going to proceed, okay? 2 pairs of brackets underneath. Now, you know that these first two terms have to multiply to give you x squared, so it's got to be x and x. Now, the complication is what goes here. Now, you know that your choices are 10 times 1 or 5 times 2. These are the only choices that you have that can go here because they have to be factors of this last number, okay? So what we're looking at is these two possibilities, and they need to combine through an addition or subtraction somehow to give you the middle number. And hopefully you can see that it's going to be a 5 and a 2. And plus 5 and plus 2 give you 7, okay? And 5 times 2 give you 10. So if I was going to ask you to do this via if you looked at a rectangle diagram now here too, right? It would be boom, x and 5 and an x and a 2. That'd be x squared. That'd be 5x. That'd be 2x, and that'd be 10. So you can see that x squared plus 7x plus 10 is indeed the correct way to factor that trinomial. Okay. Let's look at another one. So what I'd suggest you do is you write out the trinomial. You put 2 sets of brackets in the bottom. It's always going to be the first x and x because multiplying those out gives you x squared. Now we're looking at 8. So it's 8 times 1 or it's 4 times 2. And I'm looking to get a negative 2. So that's not going to work. How do I get a negative 2 from 4 and 2? Well, 4 minus 2 would give me 2. That's a positive 2. How about 2 minus 4? That gives me negative 2. So it's the 2 is positive and the 4 is negative. And you can always check your answer to see if you got the right factors. Okay? Now we'll play with algebra tiles in class. If it helps you out, great. If not, well, let's just keep working on the same thing. I do a bunch more here, okay? Now let's do the same thing again, okay? So x squared minus 12x plus 35 bracket and a bracket, x and an x. So 35 times 1 is one option, 7 times 5 is another. Signs can be an issue here sometimes because the mixture of positive and negative. I need to get a negative 12. This one obviously won't work, so negative 7 and a minus 5 would give me negative 12. But this is a plus 35. Does that make sense? Minus 7 times minus 5 is plus 35. Absolutely it does. Okay, let's look at another one. Here we go. X squared minus 8x plus 7. So x squared minus 8x plus 7. Break it down into two factors, x and an x. 7 only has one choice, 7 times 1. But what are the signs? Okay, I don't have any other choices. I want a negative 8, so boom and boom. Now notice that if they were a plus, it would be like this. Okay, and sometimes this is a minus and that's a plus, or that's a minus and that's a plus. Lots of different combinations, lots of different types of questions that we can have, okay? Let me show you a couple more here. We just did that one. Let's look at this one. Okay, so now x squared plus 7x minus 18. So boom, x and x. 18 has 18 times 1, 9 times 2, 6 times 3. Which of those are going to combine somehow through addition and subtraction to give you that 7? No, boom, here, need a positive 7. So plus 9 minus 2. That's going to give you negative 18. Plus 9x minus 2x gives you 7x. Alrighty, well, here's another one. This might confuse you at first, but remember we talked about being in ascending order or descending order. This one's in the wrong order. Put it in the right order. There you go. And now, let's factor it out. Well, it's not going to be an x, is it? But it's going to be a d and a d. Now 24 times 1, we have 12 times 2, I have 8 times 3, and I have 6 times 4. Which of those is going to give me a negative 5, right? Well, no, 8 and 3. So I need a negative 5. How are you going to combine 8 and 3 to give you negative 5? You might be asking me, does the order matter? No, it doesn't matter if the d plus 3 comes first or the d minus 8 comes first. It's the same as saying 3 times 4 is equal to 4 times 3. So order does not matter. Okay? Now, I'm going to give you one last question here that's a little bit more complicated. You can probably see that this is a little more complicated, but I'd like you to see if there's something you can do this first. Hopefully you can see that you can take a GCF out. What is your GCF? And I would suggest taking out the negative of it. So you have negative, hopefully you can see it's negative 4. So you're going to have negative 4 on the outside, leaves you with t squared plus 4t minus 32. And then we're going to break this thing down into two brackets. The minus 4 still has to stay there, right? You know it's going to be a t and a t. 32 times 1, you have 16 times 2, you have 8 times 4. I think those are all we need. That's not going to give me 4. That's not going to give me 4. That one will. How am I going to get a 4 out of that? Well, it has to be a plus 8 and a minus 4, and you're done. Okay, folks, these are the beginning of the trinomials. They become a little bit more complicated. You need to get these sorted out. Okay, so I will have lots of sheets or lots of examples for you. There's going to be lots of examples in your book. Do as many of them as you can. The key with these right now is to put them in the right order, factor out a common factor if you can, to simplify it, to make your life easy.